Hi, I'm Joseph Abrams.
I'm David Acevedo.
And I'm Tom Korsgaard, and this is Lab 8, Fraunhofer diffraction or single slit diffraction.
Hi, in this experiment we're talking about single slit diffraction. As you can see on the computer, when we have a single slit, we get this sort of diffraction pattern. Now this experiment, when it was originally done, was proof of the wave nature of light, because light going through a small slit, instead of appearing as a beam, spread out onto a screen.
The setup of this experiment is as follows. We start with a laser, and we shine it through a single slit of a known width, and then the beam travels down to this detector over here. You can't see it very well in the light, but it generates a little diffraction pattern that we can detect. It's attached to a stepper motor that moves the detector so we can pass through the diffraction pattern and measure the intensity of the light at each position. And then we can calculate the angle of these diffraction interference maximum and minimum because we know how far away the slit is from the detector.
This here is our single slit selector. By moving it back and forth, we can choose a single slit of a certain size and compare the results we get for each. So the laser shines through here, goes through a slit of whatever size we choose, and then it will go to a sensor here, which is driven by a step motor. The way the step motor works is that there's a switch on the top which can determine in which direction it goes, clockwise or counterclockwise. And in order to turn it on, you first hold down this button back here, which will show that it's ready, and then you push the start button. So as you can see, it is slowly moving to the side, and if we were to run our program, it would then be able to detect the diffraction grating and graph it.